Okay, ladies and gentlemen, I'm going to do a couple of problems on a section 4.5 on computing various probabilities. This will give you some different looks and help you when you go to do ALEX. I'm going to do problem number 1 in section 4.5. Let's go take a look at it. Let's see. Okay, problem number 1 says find the probability of getting 2 face cards. And face cards are like a jack, queen, or kings when 2 cards are drawn from a deck without replacement. Okay, so we're going to look at this problem here. So we want to compute the probability that we draw a face card on the first draw and a face card on the second draw. That's going to be equal to the probability that we draw a face card on the first draw times, given that we draw a face card on the first draw, that we draw a face card on the second draw. So this is a conditional probability. And we have to use a conditional probability because these selections from the deck are without replacement. Okay. So what's the probability of drawing a face card on the first draw? Well, how many face cards are there in a deck of cards? Well, there's a jack, queen, king for each of the 4 suits. So that's 3 times 4. There's 12 face cards. Jack, queen, king of hearts, jack, queen, king of diamonds, jack, queen, king of spades, jack, queen, king of clubs. Right, so you have 12 out of 52 chances of drawing a face card on the first draw. If you keep that face card on the deck and then reach in and pull out another card, what's the probability then that the second face draw is a face card, given that the first one was a face card? Well, we only have 11 face cards left out of 51 cards left. So this is going to be the probability of drawing 2 face cards without replacement. You multiply these fractions together and you get 132 over 2,652, which I reduced by 12 down to 11 over 221. So your probability is 0.0498. So that's problem number 1. Okay. All right, the next one I want to look at is number 2. Suppose cards are numbered 1 through 10 and are shuffled and dealt face down. What is the probability that they are in order? So we have 10 cards, each with a number on them, 1 to 10. They're shuffled and they're dealt face down. What is the probability that they are dealt in a specific order? Well, how many different ways can we have order in these cards? There's 2 different ways. We could have them ordered from smallest to largest, 1 to 10, or they could be dealt from largest to smallest, 10 down to 1. So there's 2 ways to deal these 10 cards and then be in an order. Out of how many different ways can you deal 10 cards and have them take on any other specific order or to take on any order in general? So the probability that the cards are dealt in order is going to be 2 ways. There's 2 ways to deal them in order, divided by 10 permuted 10 ways of dealing 10 cards in any specific order or unique order. And so this is going to be 2 divided by a huge number here, 3,628,800. And when you do the division, you get a decimal that's very small, 0.00000055 approximately. So that's the probability of dealing these 10 cards and them coming up in either this order or this order here. All right, problem number 3. A university received 10 applications for 4 scholarships. If 5 applicants are men and 5 applicants are women, find these probabilities. A, what's the probability that all applicants selected are women? So what's the probability that all applicants selected are women? Well, how many ways can we select women if order does not matter? We have 5 women to select from, and we're going to try to put together or we're going to select 4 applicants from these 5 women. So 5 in combination with 4 is the number of ways of selecting 4 women from 5 women where order does not matter, times, technically, we would be selecting 0 men from 5 men, excuse me. So 5 in combination with 4 is the number way of selecting 4 women from 5 women, times 5 in combination with 0 is the number way of selecting 0 men from 5 men. So the number of ways we can select 4 applications, and them all being women, would be 5 divided by the total number of ways of selecting 10 applicants, of selecting 4 applicants from 10 applications would be 10 in combination with 4 is going to be 210. 5 divided by 210 reduces down to 1/42. So that's the probability of selecting all applicants that are women, or selecting 4 applications that are all women. All right, for B, says, what's the probability of selecting 2 men and 2 women? So the probability of selecting 2 men and 2 women, how many different ways from 5 women can we select 2 if order does not matter? That'd be 5 in combination with 2, times how many ways from 5 men can we select 2 men? That'd be 5 in combination with 2. Notice the sum of 2 and 2 must be equal to the total number of applicants we're trying to select, which is 4. Okay, so 5 in combination with 2 times 5 in combination with 2 gives us 100, divided by the total number of ways you can select 4 applicants from 10 applications, 10 in combination with 4. 100 divided by 210 reduces down to 10/21. And that's your answer for B. All right, for C, what's the probability of selecting 4 applicants and none of them being women? Well, that's equal to this probability, the probability that no women are selected when we select 4 applicants. That is equal to how many ways can we select 0 women from 5 women? That'd be 5 in combination with 0, times. Now, if we select no women, that means all the selections were men. So that means we selected 4 men applicants. So how many ways can you select 4 men from 5 men with order not mattering? That'd be 5 in combination with 4. So 5 in combination with 0 times 5 in combination with 4 is 5, divided by the total number of ways of selecting 4 applicants from 10 applications, which is 210. 5/210 reduces down to 1/42, and that's your answer. Now for D, what's the probability of selecting 3 women and 1 man? 3 women and 1 man. Right, so the probability of selecting 3 women and 1 man is going to be equal to the number of ways of selecting 3 women from 5 women, where order does not matter. That's 5 in combination with 3, times, and selecting 1 man from 5 men, where order does not matter. 5 in combination with 1. And of course, that's divided by 10 in combination with 4 again. That's going to be 50 divided by 210, which is 5/21. And that's your answer for that problem there. All right, problem number 6. Let's look at this one here. A package contains 12 resistors, 3 of which are defective. If 4 are selected, find the probability of getting A, 0 defective resistors. Well, we got 12 resistors. 3 are bad and 9 are good. So what's the probability in A of selecting 0 bad resistors? Well, the probability of selecting 0 bad resistors is equivalent to selecting 4 good resistors. So how many ways can I select 4 good resistors if order does not matter? That's going to be 9 in combination with 4, because we have 9 good resistors. 9 in combination with 4 times the number of ways of selecting 0 bad resistors among 3 bad resistors is 3 in combination with 0. Notice again, 4 plus 0 is equal to the total number of resistors that we're selecting, which is 4. divided by the total number of ways of selecting 4 resistors from 12 resistors total is 12 in combination with 4. 126 divided by 495, I reduced it down by 9 down to 14 over 55. And that's your probability of selecting 4 good resistors or no bad resistors. That's for A. Now for B, what's the probability of selecting 1 defective resistor? The probability of selecting 1 bad resistor is equal to the probability of selecting 1 bad and 3 good resistors. Because again, remember, we're selecting 4 resistors. So 1 bad and 3 good is the same thing as saying the probability of selecting 1 bad resistor. Well, how many ways can I select 1 bad resistor from 3 bad resistors where order does not matter? That's 3 in combination with 1. Times how many different ways can I select 3 good resistors from 9 good resistors if order does not matter? 9 in combination with 3. Divided by 12 in combination with 4. That gives you, after you reduce this fraction down by 9, this gives you 28 over 55. That's your probability of selecting 1 bad resistor, 28 over 55. C was the probability of selecting 3 defective or 3 bad resistors. The probability of selecting 3 bad resistors is equal to the probability of selecting 3 bad and 1 good resistor, because again, we're selecting 4 resistors. How many ways can you select 3 bad resistors from 3 bad resistors? Order does not matter. 3 in combination with 3. Times, what's the probability of selecting 1 good resistor from 9 good resistors? Order does not matter. 9 in combination with 1. Divided by 12 in combination with 4. 9 over 495 reduces down to 1 over 55. And that's your probability for part C there. All right, now I'm going to do problem number 7. A meeting of 10 executives, 7 women and 3 men. At a meeting of 10 executives, 7 women and 3 men, 2 door prizes are awarded. Find the probability that both prizes are won by men. All right, so what's the probability that both prizes are won by men? In other words, that's equal to the probability that a man won 2 prizes and a woman won 0 prizes. Well, we have 2 men. We have 3 men, and the number of ways of awarding 2 prizes to 3 men where order doesn't matter. We don't care who won, the prizes. There's no distinction between first and second prize and all that. So 3 in combination with 2 is a number of ways in which to award 2 prizes to 3 men, times technically the number of ways of awarding 0 prizes to 7 women, 7 in combination with 0, divided by, we have 10 total people, 10 executives. So what's the number of different ways of awarding 2 prizes to 10 executives where order does not matter? So this probability is going to be 3 divided by 45, which is 1 over 15. And that's your answer. That's the probability that both prizes are won by a man. All right. Problem number 9. A small car dealer has 4 white automobiles, 3 red automobiles, and 2 gray automobiles at the lot. If a dealer sells 3 automobiles over the weekend, find these probabilities. What is the probability that all 3 automobiles sold are white? So the probability that all 3 sold are white is equal to the probability that 3 white are sold and 0 red automobiles are sold and 0 gray automobiles are sold. Well, this first probability here, 3 white are sold. We have 4 white automobiles to choose from, and we're going to sell 3 white automobiles from those 4. So the number of ways of selling 3 white automobiles from 4 white automobiles where order does not matter is 4 in combination with 3 times technically the number of ways of selling 0 red automobiles from 3 red automobiles is 3 in combination with 0 times the number of ways of selling 0 gray automobiles from 2 gray automobiles is 2 in combination with 0. Notice 3 plus 0 plus 0 must be equal to 3 because we're selling 3 automobiles. That is going to be divided by the fact that the number of ways of selling 3 automobiles from 9 total automobiles. There's 9 total automobiles. 4 plus 3 plus 2 is 9. 9 in combination with 3 is the number of different ways of selling 3 automobiles from the 9 automobiles we have on the lot. You take 4 divided by 84, and that gives you 1 over 21. That's the probability that all 3 vehicles sold are white, 1 over 21. What's the probability in B that 2 automobiles sold are red and 1 is gray? Okay, that is going to be down here, part B. I'll come back to this one next. The probability of selling 2 red automobiles and 1 gray automobiles is equal to, okay, the number of ways of selling 0 white automobiles among 4 white automobiles, that's 4 in combination with 0, times the number of different ways of selling 2 red automobiles from 3 red automobiles we have, 3 in combination with 2, times the number of different ways of selling 1 gray automobile from the 2 gray automobiles we have on the lot, 2 in combination with 1, divided by 9 in combination with 3. When you crank this out on your calculator, you're going to get 6 over 84 or 1/14. So 1/14 is the probability of selling 2 red and 1 gray automobiles. For C, what's the probability of selling at least 1 automobile that is white? So what's the probability of selling at least 1 white automobile? Probability of selling at least 1 white automobile is equal to 1 minus the probability of the complementary event that none of the automobiles sold is white. So we have to figure this probability out, which is really equal to our original probability. So that's going to be 1 minus. Now, what's the probability of selling no white automobiles? Well, that could occur a couple of different ways. We could sell 3 red and 0 gray automobiles, or we could sell 2 red and 1 gray automobile, or we could sell 1 red and 2 gray automobiles. Now, we cannot sell 3 gray automobiles because we don't have 3 gray automobiles. We only got 2 on the lot. So this is going to be equal to 1 minus, now, what's the probability of selling 3 red and 0 gray automobiles? Well, the number of ways of selling 3 red automobiles from 3 that we have available is 3 in combination with 3, times the number of ways of selling 0 gray automobiles from the 2 that we have available on the lot is 2 in combination with 0, divided by 9 in combination with 3. Or means addition. So plus, what's the probability of selling 2 red and 1 gray automobile? Number of ways of selling 2 red automobiles from the 3 we have available is 3 in combination with 2, times the number of ways of selling 1 gray automobile from the 2 we have available is 2 in combination with 1, divided by 9 in combination with 3. Or means plus. The number of ways of selling, the probability of selling 1 red and 2 gray automobiles, how many different ways can we sell 1 red automobile from the 3 we have available? Order does not matter, 3 in combination with 1, times the number of ways of selling 2 gray automobiles from the 2 we have selected, with the 2 we have available in our lot, rather, is 2 in combination with 2, divided by 9 in combination with 3. Well, this ratio is going to be 1 over 84. This one will be 6 over 84, and this will be 3 over 84. And then when you add these fractions together, they have a common denominator. It's 10 over 84. That's going to be 1 minus 10 over 84, which is 84 over 84, minus 10 over 84 is 74 over 84, which is 37 over 42. So that's the probability of selling at least one white automobile, 37 over 42. Finally, D, what's the probability of selling no red automobiles? Well, that can occur in a couple different ways. That is equal to the probability of selling 3 white and 0 gray automobiles, or 2 white and 1 gray, or 1 white and 2 gray automobiles. The first probability is computed this way: 4 in combination with 3, because the number of different ways of selling 3 white automobiles from the 4 we have available on a lot is 4 in combination with 3, times the number of ways of selling 0 gray automobiles from the 2 we have on a lot is 2 in combination with 0, divided by 9 in combination with 3. Or means plus. How many different ways can we sell 2 white and 1 gray? 4 in combination with 2 is the number of ways of selling 2 white among the 4 white we have available, times the number of ways of selling 1 gray of the 2 gray we have available, 2 in combination with 1, divided by 9 in combination with 3. Plus, what's the number of different ways of selling 1 white and 2 gray? How many ways can we sell 1 white among 4 white available? Order does not matter. 4 in combination with 1, times how many ways can we sell 2 gray of the 2 gray we have available? 2 in combination with 2, divided by 9 in combination with 3. When you do all these ratios, you get this. And when you add them up, you're going to get 20 over 84. And by 2, that reduces down to 10 over 42. And then that further reduces down to 5 over 21. So that's the probability of that one there. Okay, so hopefully by seeing some of these probabilities computed, that'll help you better with Alex when you go to do the homework quiz and or the exam.